All right, hello everybody. Obviously, I'm not here today, so I recorded this lesson, lesson 8 of Unit 6 for you. So let's start with the ISAS practice questions. All right, first one. Today, Miss Madison will teach 4 students how to use a computer program. Each day after that, she will teach 2 additional students. Which of the following expressions represents the number of students Miss Madison will have taught to use the computer program at the end of 5 days? So she's teaching 4 students today. And then after the first day, she's teaching 2 students a day, 2 students a day, um, for a total of 5 days. So this is day 1. Okay. And then from the second day on, from day 2 to day 5, okay, so day 2 to 5, she's going to she's teaching 2 students a day. So this case, it's going to be 2 times 4 because days 2 through 5 is 4 days. So on the day 1, she taught 4 students. On days 2, 3, 4, and 5, she taught 2 students a day for those 4 days. So which one matches up with this? It looks like it's going to be choice E because 5 minus 1 is 4 here. So number 1 is choice E. Okay. Number 2, William used an equation to determine the fraction equal to 0.31 repeating. The first few steps of his work is shown. What is the answer? All right. So let's go ahead and solve this equation from here. So this is 100x minus 1x, which is 99x. So this is 99x equals 31 because, again, 100x minus 1x is 99x. And then because this is multiply, I'm going to divide both sides by 99, and I get x equals 31 divided by 99, which is choice A. So number 2 is choice A. Okay. So that's it for the ISAS questions. Let's get into the examples for today. Today we're going to talk about finding equivalent expressions. Finding equivalent expressions of quadratics using the area model or the box method. So let's take a look at this here. Applying the distributive property to multiply out the factors of or expand 4 times 2x plus 2 gives us 4x plus 8. How are they getting at? They're doing 4 times x, which is 4x, and then 4 times 2, which is 8. So we know the 2 expressions are equivalent. We can use a rectangle of side lengths x plus 2 and 4 to illustrate this multiplication. So essentially, they create a box, okay, where this is x plus 2 and this is 4, and they use this to multiply that out. They treat this like those old multiplication or times tables that you used to use when you were younger and first learning multiplication. So they do this by saying, okay, this one is going to be 4 times x, which is 4x, and then this one is going to be 4 times 2, which is 8, all right? And that's where they get the 4x plus 8 from, okay? Draw a diagram to show that n times 2n plus 5 and 2n squared plus 5n are equivalent expressions. So we're going to do something similar here. I'm going to create a box, and I'm going to create a 1 by 2 box because this is one expression. So I'm going to put an n here, and then I'm going to do 2n plus 5 up here. So 1 row, 2 columns, or you could do 2 columns in 1 row. And then I'm going to multiply this out just like I explained up there. Okay, so this is going to be n times 2n. Okay, I can think of this as 1n times 2n. Okay, so 1 times 2 is 2. And then n times n, we should know that when we multiply, we add the exponents. So n to the first times n to the first is going to be 2n squared. Okay, so n times 2n is 2n squared. And then if we do the other one, if we do the other one, okay, which is n times 5, or 5 times n, 5 times n is going to be 5n. And if we put that together, we get 2n squared plus 5n. So draw a diagram to show that this and this are equivalent expressions. We just did that using the area model or the box method. Okay, so again, this is called the area model, or I will sometimes refer to it as the box method. Either one works. Okay. Let's take a look at number 2. All right, for each expression, use the distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. So I'm going to do this by drawing a diagram. Okay, so for A, okay, all right, let me use a different color here. I'm going to do 6, and then this is going to be 1/3 n plus 2. Let me zoom in on this so you can see it better. Okay. So now I'm just going to multiply this out. So 6 times 1/3, okay, 6 times 1/3 n. Okay, if you have to, use a calculator, but 6 times 1/3 is 2, so this is going to be 2n. And then this one right here is going to be 6 times 2, which is 12. So the answer is 2n plus 12. Okay. B, we're going to do the same thing. So I'm going to do a diagram. I'm going to draw a box. So this is going to be P, and this is going to be 4P plus 9. Okay. So if I think of this as 1P, okay, if I think of this as 1P, let me change the color. Okay. So 1 times 4 is 4, and P times P times itself, anything times itself is squared. So this is 4P squared. And then the other one is going to be 9 times P, which is 9P. So the answer is 4P squared plus 9P. So that is your answer for B. And then let's take a look at C. Again, let's do the same thing. Okay. So this will be 5R, and this will be R plus 3/5. Okay. So that one is going to be, let's see, 5. This first one is 5 times 1, which is 5. And then R times R is R squared. So 5R squared. Okay. And then 3/5 times 5R. Okay. So I know the answer is going to have an R in it. Maybe I don't know what 3/5 times 5 is. So use a calculator if you need to. There's no shame in having to use the calculator. So 3/5. Okay. 3/5. I'm going to enter it as 3 divided by 5. 3/5 times 5 is 3. Okay, so this is going to be a 3r. So put it together, I have 5r squared plus 3r. So that's your answer to C. And then let's do D. Okay, so this one is 0.5w plus 7 times w. So again, I'm going to draw a box with 2 columns, 1 row, or 1 row, 2 columns. So I'll put w here, and this will be 0.5w plus 7. Okay. So 0.5 times 1. Okay. 0.5 times 1 is going to be 0.5. And w times w is w squared. All right. And then this last one here, 7 times w is 7w. So put that together, that's 0.5 w squared plus 7w. Okay, that's your answer for part D. Okay, so that's it for the front. Let's take a look at the back now. Okay, so let's go to the back of the handout if you're following along. So here is a diagram of a rectangle with side lengths x plus 1 and x plus 3. Use this diagram to show that x plus 1 times x plus 3 and x squared plus 4x plus 3 are equivalent expressions. So notice in this case, they were multiplying here, they were multiplying a binomial 2 terms times a binomial 2 terms. So they created a box or a rectangle with 2 rows and 2 columns. So to multiply this out, they created that box, and they're going to do the same thing that we did on the last one. So I'm going to go here and here, all right, and that's going to be x times x, which is x squared, okay? And then this one right here is going to be 3 times x, which is 3x. And then the bottom left is going to be 1 times x, which is 1x, or just x. And this last one is going to be 3 times 1, which is 3. And if I put this together, I get x squared. Okay. And then I have 3x and 1x. 3x and 1x is 4x. And then this last one here, I have 3. So x squared plus 4x plus 3. Okay? Use this diagram to show that x plus 1 times x plus 3 and x squared plus 4x plus 3 are equivalent expressions. Have we done that? Yes, we have. Okay? So we're going to do the same thing on these 5 examples down here. So let's take a look at A. Okay? So on A, I have x plus 5 squared. So that's going to be x plus 5 times x plus 5. Okay? And I'm going to do the same thing. I'm going to create a 2 by 2 rectangle, or a 2 by 2 box. So this will be x plus 5, and this will be x plus 5. And I'm going to fill in that table there. So this will be x times x, which is x squared, 5 times x, which is 5x. Okay, this one will be 5 times x again, so that's 5x. And then 5 times 5 is 25. Okay, if I put that together, I have x squared. Okay, then I have 5x and 5x, so that's 10x plus 25. So that's your equivalent expression for part A. Okay. So that's your equivalent expression for part A. Part B. Okay. So this is, so I'm going to do another one. I'm going to do two, let's see, I'm going to do two columns in one row. So this will be 2x and this will be x plus 4. Okay. So this is just like the other side. So 2 times 1 is 2. X times x is x squared. And 4 times 2x is 8x. Put that together, I have 2x squared plus 8x. Okay. C. Okay. C, I have a 2x plus 1 times x plus 3. So I'm going to need to do a 2 by 2 box again. So I'll do 2x plus 1 up here. And I'll do x plus 3 down here. And let's multiply that out. So the top left is going to be 2 times 1, which is 2. X times x, which is x squared. Okay, top right is going to be 1 times x, which is 1x. Bottom left is going to be 3 times 2x, which is 6x. And so that was bottom left. Bottom right is going to be 3 times 1, which is 3. All right, if I put all of this together, okay, let's put all of this together, and I have 2x squared. Then I have 1x and 6x, which is 7x, and then plus 3. So that's your answer for C. Okay. D and E, we're going to do the same thing. So let's create, again, a 2 by 2 box. So this will be x plus 2, and then x plus 6. Okay. Let's multiply that out. So top left is x times x, which is x squared. Top right, this is 2 times x. So that's going to be 2x. Bottom left is going to be 6 times x, which is going to be 6x. And bottom right is going to be 6 times 2, which is 12. If I put everything together, I end up with x squared plus 8x. All right, 6x and 2x is 8x plus 12. Okay? And then lastly, E. All right, E is basically the same problem, just different numbers. So again, I'll create a 2 by 2 box. And let's see, I'll do x plus 5 over here. And I'll do 2x plus 10 up here. And I'll multiply it out again. So 2x times 1x. So 2 times 1 is 2. X times x is x squared. Top right is 10 times x. So that's 10x. Bottom left is 5 times 2x. So that's going to be 10x again, right? 5 times 2 is 10x. And then the last one is going to be 10 times 5, which is 50. If I put everything together, I have 2x squared. 10x plus 10x is 20x. And then plus 50. Okay. Okay. So that is it for our lesson. Okay. So our goal for this lesson was to be able to write quadratics in different forms. Okay. So what we were doing is we were taking a quadratic that's in what we call factored form and then write it in what we call standard form by using this area model or box method. So you will be doing something similar on your cool down tonight.